Hi guys, this is Arjun. We'll be picking the first topic as binary tree data structure. So let me go through the topic. This is the binary tree. So what we need to do, what we need to consider in binary trees, like we'll have the root node. Each node, each node has at most two elements, like two children. So if we go through this image, if you see this, every node will have at most two children. Like it cannot have more than two children, and it can have only one child, and it can have like zero elements. So this is a simple data structure, like binary data structure. So and it contains like there will be a data for each node. See, if you consider this root node, there will be one. This is the value, and then there is a left pointer which will be pointing to the left side, and then there will be right pointer which will be pointing to the right side. So this will be the data structure, that's it, which we require right now, like in terms of definition wise. So let us solve the questions based on binary tree. So if we see the binary tree, I had picked the top 10 unread liked in the lead code questions. So we'll be solving easy questions in the binary tree, and then we'll be reading the question, and then we'll be doing the live coding. So let us pick the first one, which is binary tree in order traversal. So if you see the question, we are given a root of a binary tree, and we need to return in order traversal of node values. So if you see the example, here we are given a root, and then we are given a right, and then again for this particular node there will be left child. So if we see the in order traversal means, if you see in order traversal means, like we'll consider left and then current root and then right. So this will be the in order traversal. Like will be, let's say, in order. In means inside, right? So the root should be inside between left and then right. The root should be in between those two. That is in order traversal. So we need to return in order traversal. Like if we do in order traversal, what are the values we are getting? So we need to return that in terms of vector of int, right? So that is the question. So we need to, let's do the coding. So think like suppose we are given root, and then we have left, and then we have right, right? So we need traversal of left, right? First, before root, we need to do the traversal of left. So we should call the function which is related to left, right? And then we need to append root value. And then after this is done, we need to call right side of the function, so that it will be left, root, and then right. Right. So we'll be doing the same thing here in the coding. So let's start with the coding. So I'll be taking a vector which contains answer. So this will be storing here, and then I'll be taking one recursion function, and it will contain tree node with root. And what should be the base condition? When should we stop the traversal? Suppose if the root is null, suppose let's say we got here and then we go to right, then there will be null, right? So we should return when it is null. So root double equal to null. We need to return at that time, and then what should we do? We should call the left function first, and then root, and then right. So we'll be calling recursion root left and then we'll be adding now what is the value of root? There will be root value. So if you see the class, here we'll contain the value and then left and then right. So we'll be doing the same thing here. So recursion of root right. Now we need to call this function with root and then at last we need to return answer. I think, yeah, I think that's it. So let me run and then submit. Yeah. See, if you see the answer, we did not do anything. We just did the same thing which I had explained. Like we are calling the recursion, and then if it is null, we are returning, and then we are traversing the left, and then we are appending the current node, and then right. That's it. Yeah. So yeah, that's all for this video. Yeah, meet you in the next video. Thanks.